So this is a very similar problem to the last one. We've got 5 cos x plus 12 sin x, and we're told to write that as r cos x minus alpha. So just as before, we start with r cos x minus alpha, and we'd like that to be identically equal to 5 cos x plus 12 sin x. I'm going to expand using the double angle formula for cos a minus b here, and I'm going to multiply through by r immediately. So I have r cos x cos alpha plus r sin x sin alpha is equal to 5 cos x plus 12 sin x. Then just as before, we're going to match up the coefficients of cos x and sin x. So the number of cos x's on the left is r and cos alpha, and that should be 5, giving r cos alpha equals 5. And for the sin x, we have r sin alpha on the left and 12 on the right, so we get the second equation we'd like to be true, which is r sin alpha equals 12. Now in the previous video we mentioned that this, you can think of this as giving you information about a triangle if you're into geometry. Alternatively, if you label these equations 1 and 2, if I do equation 2 divided by equation 1, I immediately get that sin alpha over cos alpha equals 12 over 5. I've just managed to sort of get rid of the r's here, and that simplifies to tan alpha is 12 over 5. And here again we have two options for what alpha is, or rather one angle, measured either in radians or degrees. So alpha is equal to 67.38 if you're working in degrees, or if you're working in radians, alpha is actually 1.176. That one there being to 2 decimal places, and this one here to 3 decimal places. So that's how we find alpha, and you could theoretically substitute back in to find r, but it's ugly and repulsive. So what you can actually do is, if you square both equations and add them, r squared cos squared alpha plus sin squared alpha is equal to 5 squared plus 12 squared. Sorry, and that comes from doing equation 1 squared plus equation 2 squared. Cos squared plus sin squared is always 1, so we get r squared is equal to 25 plus 144 is 169. So that actually gives you r is equal to, you do actually get plus or minus 13, but I'm just going to write r as 13, because if alpha I've chosen to be an acute angle, 67 degrees, I want r sin alpha to be 12 to be a positive thing, so I want the positive square root. So there's me solving the equations, and so I can write my final answer at the bottom here, which is 5 cos x plus 12 sin x is exactly the same as 13 lots of cos x minus, I'm not doing radians this time, 1.176. So there you are.